Hello and welcome to the episode 3 of Code Deep Dive with OpenTTD. In the last episodes, I was showing game initialization logic, starting from establishing config paths, locating and scanning tar files, parsing ini files, and parsing CLI parameters, specifically logging levels. And today, I will continue where we left off. I have just read the ini files, and just let's see what happens with them further on. So we have the startup parameter as this is set to true. So there is some reset currencies logic which is not applied here. And then we use this generic ini file to apparently load some version from the config. Let's see how it works. So we know that the ini file contains groups. So we just read the group, and since it's present, we just check the item. So I believe this is something that's conditional. Yes, so we just look for the ini items, and if it's there, we just return that. Otherwise, null pointer is returned. Okay, so in this ini file, there was actually the version number, which is here, so number 7, and then from chars it will give us just a number, and this actually casted automatically to ini file version, which is enum. Okay, so 7 is, yeah, it's just some kind of version here. I'm not really sure what's the version in strategy. Yeah, so anyway, it's probably just needed to recognize, you know, how the game evolved over time, just support some older stuff. Okay, so since we have the startup set to true, we need to take a look how the graphics are set up. So this group is scanned then, and then from this group, we look up for graphics set, and then, all right, so this is some old setup first. So, which can be expected probably in older versions, but then we truly have this graphics set. Let's see how if it's here separate. Okay, so it's something like this, and in this sense, the graphics set just means probably the assets we have seen before. So we pick up the name, and here the name. Okay. And then we set the base graphics ini data name. What's that? Okay, so this is some structure here. Yeah, is this a structure? Ini data. Yes, so this is static structure ini inside the base graphics, which probably just holds. So I assume that all data functions related with replacing the base graphics. Okay, so this is probably some structure describing what the graphics is, and we just say, okay, it's this item name. Oh, can I see that? It doesn't show up. Oh, it's probably because it's not initialized yet. That's okay. One again. So it should be open. It should be OpenGFX. All right. So then there is some short name. Okay. And then the value is like this. Oh, so it's hexadecimal probably. Could be, yeah, parse integer by 16. Perfect. And then we use a byte swap for that. Okay, whatever. We can see later probably what does it mean, but it's like not obvious what this conversion is about here. And then there could be some extra version as well, and extra parameters which are not present, obviously. Okay. And then generic version, what's that? Oh yeah, we just read that. So for the split, we have to look in the generic for these settings. Handle setting. Let's dive and see. Common handler for saving, loading variables to the configuration file. Okay. So the proc we gave here. I don't see it here. Why don't I see it here? Here. In the load settings. Okay. So we pick a group name here. And then there is a settings table. And settings table just a span over setting variant. Okay, and setting variant is just this union, or actually the variant. Yeah, it's really the standard variant of all these different types. Okay. Yeah, here it is. One of many settings description. So this one, and quite a bit of stuff here. It's apparently responsible for parsing things. Save load settings flag and so on. Okay, let's see what happens with that. So get settings description. So from this variant, we just pick what this lambda will return settings description. What's that? Okay, so this is some structure with the flags, and that's how the setting would show up in the GUI. Okay, some names. Okay. Maybe, yeah, maybe without deep diving here. In the end, we have this as the, yeah, and some flags. So there are base bit set flags. And then we have a save, some version. What's that? Save version from. Okay. So it seems like there's just some validation here, and we just check if the versions are. Oh, there's some external stuff. Okay. Okay. Check if some versions from to combination falls with the range of the active save game version. Okay. Yeah, if it's what's the only starter? It's okay. It's actually set to true. So then we just it's a bit cryptic, but let's try to sort it out. So the name here is display opt. Is it something that's here actually? Oh, it's the first one actually. Okay. So we have a string of that. And then we find the dot, which is not there. All the settings, okay. Then we just pick up the group. Then we pick up the group item, display opt. Okay. It's not empty. And then we just parse it. Okay. So we have this setting as D, and we try to parse the value. In setting task. Okay. Yes, this is why I see the base here. And for this, we just have some custom, some parse value. Which means that what happens here is that we'll pick the item and then see the value if it's there. And then just parse value which is stored inside this item or get default, which I believe will be triggered. Oh, come on. Yes. Okay, I'm not really sure why I'm here. Many setting descriptions, but yeah, because this is this type of config attribute, and it's actually already initialized with some options, some vector. And then we just look up many, which means that we take the string and we just, again, we have seen this functions before in previous episodes. So we skip some separators and yeah, read the value. So we just stripped, like we just split this string into single values, and the pipe is the separating character. And then we just focus on the single value. And for some reason it tries to, it tries to read integer. It's interesting. Check if it's integer. Okay, so just try, I assume if it is, probably it just will return integer like here. But then it's not an integer, so it will just look up this string in the many, so in this array that calls all the options. And since it found one, it will cast it to, yeah, to the index, I guess, because it computes the difference between the iterators. So we have an index. Okay. And then it just set bit. Value found set it, and res is okay. So it sets the bit in this result thingy. Okay, so simple. Okay, yeah, so shifting Y and appending to X. And then we have the res is 1, and then we have our options. So in this case, the station names. So here was the show town names, then show station names, and then it's yet another different bit value here. So 1, and then it will just append to res, which will, I guess, will be 3, yes, and so on and so on. So basically it's a way to parse this kind of string with multiple values and convert it to kind of a bit field. which we have here. And it skipped a bit. Okay, but oh yeah, because it has value, so we just exit here. Okay. So for this bit field is this value, and then make value valid and right. So probably we'll disassemble that. Make value valid. It's ensuring the values between the minimum and maximum size. Okay. So the get range. Where are we actually? Init setting description. Okay, I feel like skipped something important here, and maybe it's not super obvious what it is. But since it's a null pointer, then yeah, then we'll just get this tuple, right? Max value. Yeah. So this is basically, it was set as just a byte range. And then there's some get var mem type. What's that? Get the number type of a setting. This describes the integer type as it represented in the memory. Okay, I think I've seen this GB before. Is it a function? Yeah, it's a function. It's inline, so probably we can get in. Fetch n bits from x started at the bit s. Okay. So it actually takes the bit field represented as integer and just takes a subset of bits. That's how I understand it. So in this case, there's 4. Okay, the start position of read some bits, the number of bits to read. Yeah, so first 4 bits, or actually the 4 bits after 4 bit, that's probably what it is, and then it's somehow okay, alias to integer, it's somehow shifted left by 4 bits. Okay. And then somehow we get 42. That's right, yes. Okay, and then we just test some flags, which yeah, we have seen that. Here 0 is special, whatever. And UI drop down is not set, and then just clamp. Okay, so just some security clamping function. So basically, this seems like a representation of integer values, signed or unsigned, with this kind of coding. Oh yeah, here is this shift, the shift to 4s. And it just tells which integer type we are dealing with, and then we have clamping, and the clamping depends on this min-max value we get from the range here. And then for unsigned integer, it's a bit different. Override the minimum value, no value below this min except special value 0. Okay. Yeah. And then, so after we make sure it's in the valid range, we just write it to the object. And the object is still non-pointer. The rest, okay. Get var memory type. Yeah, we have seen this. So it's not the var null. I'm not really sure what it is, but useful to write zeros in save game. Okay. So just some assert, and then save load address proc. Yeah. Okay, where are we? Press off. So this was getting some. Right, it's probably it was set up during construction and we kind of skipped that, so it's not obvious to me now what's happening here. But in the end, we just get a variable address, because this is what this function was about. Yeah, function that returns the address, the base, and extra data. Okay. Anyway, this value is somehow saved, like this one, the value 34. Sorry, this one is 239, and this one is actually a type of variable. So we basically just make sure where to write the value of given type into which place in the memory, and then there's a write value, and depending on this there's a proper casting, and this code just meant like unsigned integer with 8 bits, and that's it. And then it seems like for each setting, it feels like for each setting we just get a description, probably a different one, and yeah. So this structure actually. Okay. Okay, since this variant, yeah, one of many settings. Okay. Okay. So anyway, this will just go from the parsed any item values, which don't have really much meaning, just names and values, and then they're just put in some meaningful structures that contains real game objects. So let's exit that for a moment. I think these functions are just run over different ini files and different tables of settings. For example, this one, there are 2 settings tables. Oh, sorry, there's only one. Network private settings. Okay. Yeah, and this is just a span of settings variant. Okay. And then there are some other settings like currency, company. So all of this stuff, they just put in the correct settings objects or setting structures so that they are available to the game. Probably different modules of the game. That's how I would guess it works. Okay, and then we have basic settings, load. Okay, but this is for other event than startup, so we'll be skipping that. Okay, so we just got out from config, and then there's a resolution, which was actually, was it red somewhere? I don't remember we put that. Okay, it was parse resolution, but this never happened because it was not set in CLI. So I assume it's empty. Oh, well, empty, it's 0. It's 0, so default values. But then we have this current resolution, which was apparently set somewhere before. So here the value is 1284 in the free. Yeah, and it's exactly something that we have in the setting. So probably one of the parsing, or actually interpretation functions of all of this unifiers just set up this car resolution global, this value. And here we just want to make sure that it does not go beyond some values, like 65,000 roughly. Assume the cursor starts within the game, as not all video drivers get an event. The cursor is within the event when it's opened. Okay, so we just say it's in the window, probably matters later. And then there's some initialization of language packs. You may have a look. Where is it? Okay, so there's we're scanning again the search paths. We saw that, so maybe let's just have a look here. Fill language lists. Okay, I have a breakpoint here. So we look up some path, which is, what is this? This one. Okay, so there's some lang path. Okay. Their entry. Then we just look up the path. Catalan lang. Okay. Can I copy that actually? Yeah. Right. Oops, I didn't copy that. Oh, okay. That's not nice. I was expecting it to be copied, but how about this? Okay, much better. Okay, so there are some files. Okay, and so we have a bunch of probably language files. I mean, for sure language files. What else could it be? And we just process them one by one. So what happens here? So we have a file, and then so this is the Catalan language in this case. And then get language file header. So we just open that file, it's there, and then we just read. The HDR is language pack header. Oh, was it passed here? Okay, yeah, language metadata. Okay, let's look at this. Okay, language metadata contains the path of the file, but it inherits from language pack header, and there are a lot of things related to language, as I assume. So the name of the language, some ISA code, and so on and so on. Then there's cases, a lot of stuff. Okay, let's see what happens when we read that. So yeah, So it checks if it's valid, because expect like 1 byte to be read. Oh yeah, size of 1. Okay. HDR missing. 15 will not get, okay, I'm not really sure what it is. But apparently we checked the compatibility. Here there's nothing more, just a bit of a header. And it was correct, so good. And then there's some get language. And here we have languages, which is language list. And this is vector of language metadata. This looks like the all global things. And then there's probably just a lookup. Oh, it just skipped. I was almost sure it was not empty, but okay, so maybe it was just there. So I would assume that new GRF language is just some new format of how the languages are stored. Maybe some different translations that we just don't have there. The other possibility, which I'm reading, is that we actually push this language description to the global structure. So maybe actually let's skip here and then actually check if this ID, so this time it was 64. Okay, so you check for some kind of duplicates. That's my understanding, because if this check is done, we just get this message that, oh, you know, language ID is already known. And we just don't push yet another duplicate into this vector of languages. And it's like known if we just, like the header of this from this file, it just is the same to this ID from the header from the previous file. Okay, so we'll just fill the language list, probably to just make stuff available. And yeah, to scan along the different search paths, so that's we don't have to go through all of these. And then languages are not empty, so that's good. And then we get current local, and we scan like language environment variable. Yeah, this is actually what hits. I had it set. Which one? Okay, English US to be exact, but there are other possibilities like LCO, and if it's not set, then LC messages also can be set. This was passed as the parameter, and then also lang. So all these four options can be checked in sequence. Okay, so we have this, and then okay, there's some fallback to English one. So the first, is it like the first is a English one or what? Fallback when no local matching language has been found. But why does it say in Great Britain? It's not really sure. Okay, maybe it will be changed later. And then we go through all these languages we scanned, and we're trying to find a default language. The priority is by configuration file, local environment, and last, if nothing, found English. Okay. So here, this file was not English, right? Config language file. So we'll start in the configuration. Okay. And then reading some ISO code. Yeah, Catalan. So this was the first on our list. If it would be Great Britain, then yeah, we would probably just set up fallback. Yeah, that's why I couldn't. That didn't make sense for me, but now I see it. When we find the code, it's the British one. Then it will be just set up as a default fallback. Only autopick finished translation. Okay, so when the translation is finished, this missing. Oh, okay. So there's some scan of how many of the items are missing in the translations file. Okay. Number of missing strings. So we multiply by 4, and okay, it gives us like a 1/4. Okay. If ISO code starts with, and we just, so the string actually holds to important values. So if it matches, then we just pick up the chosen language. And here it's the same as the language fallback. Okay, let's see. So there are many languages, so we'll just not go one by one. But I assume that the chosen language will be picked up at some point, and it should be the British one, isn't it? The US, sorry, the US one. Okay, if it's if there will be no default language, then we just use fallback, which is the British one. Okay, and then there's a reading of language back. So we selected the language, and then we will read that. So what we have here is that we have some read file to memory. So we pick up this file. Let's see how it works. Yeah. So just open the file. If it's there, we just want to tell how many bytes are there in total. Okay. Okay, and then we just put the cursor in the correct place. There's also some limit. Oh, that's interesting. So there's a limit of how much you want to read into the memory, apparently. Because, you know, if it's too big, like more than, I think it's 1 megabyte, then it will not read to memory. Interesting. Probably some very old code, maybe, I would guess, where, like, you know, all of this time that 4 megabytes of memory was like a lot that you could have. And then we just allocate the memory, and then just null terminate the character, probably just the last byte to be 0, and then just read this amount of bytes. So the word size is 1 here, and then we just try to read everything. And then, okay, so actually we asked to return how much stuff did we return, and then we return mem, which is actually this unique pointer to this array of characters. Okay, so what we will do with that is that it immediately releases things. And now I just also noticed that actually this max size is here, it's set up here. Probably we just don't expect this language file to be bigger than 1 megabyte, and we just need to set up some limit. So my bad. I mean, it's not necessarily that it's a limit from the old times. It's just some sensible limit. And then we just release the pointer here, and we map it directly, the memory content, to this language pack. And this language pack is just list of strings here. And there's also some header with, I think we already saw that. This genders, cases, things, plurals. Okay, so this gives us eventually the unique pointer to this language pack that we just read. And there's also some custom deleter which will just delete all the characters. Okay, that's interesting because it will just say, yeah, just treat it as a array of character strings or character pointer and just delete them. Which actually makes sense because we actually make here the pointer to character arrays. Okay, and here's the length. Okay, interesting. I'm not really sure if I interpret that correctly. Probably not. Language pack is in fact reinterpreted character. We need to reinterpret it back to free it properly. Yes, that makes sense. Oh yeah, because we use here the brackets, so it's actually just like a. Yeah, why is it here a bracket? Okay, it's definitely like the size of the whole file. So we read it once, and then we just cast it back, and then yeah, since this is like a character array, we just run delete of the array. Yeah, so it makes sense. Yeah, now I see how it's designed. Okay, so length pack is read from the file, and then we just pick up the pointer to the last item, and we just check if it's valid. It is. There's something inside. And then we have some array of, what is it? End of language files, 32. Tab start and tab num. So out of this, we will just pick up some offsets. Okay. Some conversion. We do some byte swap here. So what did it end up with? Okay. Seems like the same number. If it's bigger than not. Okay, so it seems like some offset allocation, maybe. Because we have like the offsets here. There are like 32 offsets. Something like this. Okay, let's see how this will end up. And then we have this data, which here actually it's interesting because it seems like it's just empty string, or the string with just 0 inside. So you just go over this amount of items. Okay, and just cast it to length, which is 0. If 0 plus 0 is bigger than n, then just return. But this is not the case. If it's bigger than this, 192, not really sure why, then do some conversion. And here, strings. Oh, this is this vector of views. Okay, let's see what it will generate. Okay, the length is always 0 so far. It's interesting. Okay, let's see here. Okay. Okay, so it seems like it just parsed all type of different phrases from the game. So in total, like almost 5,000 phrases. And this is what was the loop about. So the count was the total number of these entries, and then it was just a matter of somehow telling. Probably it was encoded like this. So there was the length first of the string to be expected, and then there was just a string. So we need to know what's like the offset, which was like shifted here with every iteration, and then how many bytes. And this was filled as a vector of the string views. Okay, and there's an assertion that the number matches what we scanned before, and then all these things like language packs are just fill in the global variable. Text direction, yeah. So whether we have left to right or right to left, exactly. And then we have this. This is probably just a global setter function. So we have this language ID somehow set up. So the one that we scanned from the file, that's what I would assume, which is 0. Okay, maybe it was 0. And list separator. So, okay, so all like the local related things. Like a string. So how does it work? Let's see. So we build on top of the result. Oh, it's empty. Okay. And then there's some string ID. Do we have some params? No. Okay. Get string with args. Okay, I would say that we just have this ID of the string in the language pack. So every item in this language pack has its own ID, and we can get an index out of that. For example, this one. Oh, what is it? Strong type def. The index offset of a string within a strings tab. Yeah, okay. Okay, so it looks like some like a packed structure, and we just end up with 0. All right. Not really sure what will be next then. So This is a structure. Some mixing. Okay. And then the same here. Tab 0. Okay. No default for this one. Format string. Okay. Again, we have a string tab. And again, it's just some default. And then we pick up. I think I don't understand fully this function. Extract the string tab. What is string tab really? To group string IDs. Tabs 0 to 1 for regular strings. Okay, is it like some... It's probably some just kind of group indeed. Town, industry. So this is what the tab is called here. So from the number, we just get the index of this tab, and then we can access this array lang tab here. And then there's some offset again to the string identified by this number. And once we have that, okay, it's interesting, it's 220. And then we can look up with this offset in the strings in the language pack. So this way we can actually pick up, like just by having this ID, we can just pick up the correct translation from the lang pack, like the global one. And then we just get a string view. And then there's also formatting, but I think there are no extra arguments here, so I would expect nothing will really happen here. Yeah, so all of these things are just empty. Okay, is color safe? Okay, interesting. Is color safe? What does it mean? Test if a string contains color codes and it's not right. Okay, so so it's not only translation, but it's also translation with style apparently. So we can have special characters which just tell you the style of the text. I don't think for this one we will have some. But it will just return Boolean value. In case it finds it's not color safe, it will just say, okay, it's not. Yeah, and this is like false because it's color safe. Okay. Arg set offset. String parameter set offset. Okay. Not really sure. What are I thought that args were empty, and probably I was wrong. Okay, it was empty, but still we set some offset on top of that. Okay. Okay, I was thinking that this is actually something that's just a quick go, this formatting, but it's apparently not. Let's see. So, you know, what I actually imagine is that the formatting is when you have special just characters that in this translation, and it just allows you to inject some stuff there. But we don't have really anything like this, so I'm surprised that we are here. So I'm either wrong, or we will just exit soon out of this loop. We're not. Okay. I don't really feel like going through all of this. Maybe we can just quickly just have a look what the builder is. I just build something. Okay, 2 dots. I think I felt like there were just 3 dots there. Yes. Yeah, and that's it. Yeah, 3 dots. So maybe it feels like it just scans through the whole string anyway. And if there are some formatting special characters, then just formats the string according to arguments, but there were none. So in the end, we should get the string in the builder, and we can just get the result here. And we are back in the read language bag over here. So for this one, we are just looking for ellipses here. And basically, this is how we just retrieve the string from the language bag. So that's like the single string of given ID. So this is it 220? Probably yes. Yeah, exactly. So okay, so we can also have a quick look. So there's some no, it's not a table. It's actually the list of constant, like the list. Okay, it's not a list. It's just, you know, statements of constant string IDs, which we can probably refer just to our language bag and just pick up the correct translation. Okay, what do we have next here? We have some local creation. So we had our ISO code. And okay, ICU is some library I don't have a code for, apparently. So this will just not work. But well, we are just creating some collator. I don't know much about ICU, so let me just skip that. I believe it just sets the some collator for the current local. It's, I think, also optional. It doesn't have to be here. Okay, so here we are. I think that what's left here is some layouter and yes, and so somehow it seems like the reorganization of this data, like language related data, and after that I believe we are done with reading the languages. The next what is ahead is font caches, and then into Windows systems, which I will leave for the next session. And for now I'll just leave the breakpoint here, and let's see what comes next in the next episode. If you like this video, make sure to press like button and subscribe. I hope my content will help you creating something great. Thanks for watching.